Ladies and gentlemen, today we're going to talk about ratios and proportions and percent of change. So to do that, the skills we are working on, we're going to talk about explaining each step in solving a simple equation by utilizing properties of equality and constructing viable arguments to justify solutions. We will solve linear equations and inequalities in one variable, and we're going to use units as a way to understand problems and guide the solution of a multi-step problem. To do that, we're going to work on the math practice of attending to precision. So first, we have some vocab in this section. The first term is the word ratio. A ratio is a comparison of two numbers by division. So this is what it looks like, is we'll have two fractions that are equivalent to each other, and we'll need to solve them. A proportion, then, is that big idea. The ratios, when we set them equal to each other, we have a proportion. A ratio is that individual fraction unit. Set them equal, we have a proportion. A rate is the ratio of two measurements that have different units of measure. For example, the McPick 2, where you get two Big Macs for $5. But if I want a unit rate, I need to have the denominator as a value of 1. So a rate expressed with the denominator quantity of 1, like 25 miles per hour. And in that per hour is implied per 1 hour. Scale is a ratio or rate between the actual size of an object and the size of its model. So we're talking about scale models when we're talking about scale. Like if I build a model of a school, and then I can use that to represent the size of a full school, but I have a ratio of like 1 foot equals 1/4 of an inch. Percent of change is a ratio that compares the change in a quantity to its original amount. So it can be an increase or a decrease. We're going to talk about some examples here, but things like sales tax, which Montana kids are not as familiar with, or tipping on a restaurant bill, those are things that increase, so those are percents of increase. Or if you have things like a sale price on an object would be a percent of decrease. So let's practice solving some proportions here. And there are many different ways to address proportions, and I'm going to show you two different ways. With the first one, I'm going to show you the method that some of you may have figured out or learned in the past that was like butterfly proportions, where you multiply, you cross multiply, and you get the cross product. When I do that, I get n times 8 is equivalent to 12 times 3. Well, I know that I can simplify 12 times 3, and I get 36. My last step is to divide by 8, and I get n equals 4.5. Now the other way that we can do it, and this is the way that I find more useful, is we can deal with it as a multi-step equation. And so the first thing I'm going to do when I look at this sample B here is I want to get rid of that divided by 12. So to do that, I'm going to multiply both sides by 12. And I'm left with k plus 4 equals 12 times 3 over 4. Now when I'm multiplying by fractions, again, there's many different ways to address it, but I can simplify first. And so 12 over 4, well, that gives me 3. I wind up with k plus 4 equals 9. If I multiply across the top and the bottom, I get 36 over 4. Either way, my fraction will simplify to 9. And my last step, I need to take away 4 from both sides, and I find a value of k equals 5. Two different ways to do it. I don't care which way you do it, as long as you can show your work to walk me through the steps of how you solved that proportion. So now let's practice with a word problem. On Monday, a restaurant made $545 from selling 110 pineapple upside-down cakes. If they sold 53 pineapple upside-down cakes on Tuesday, how much did they make? Well, the first thing I want to do is I need to write out a proportion. So what I see is that they have $545 of profit per 110 pineapple upside-down cakes. I want to set that equal to the 53 pineapple upside-down cakes that they made, and I want to determine their profit. In both situations, I need to have the same numerator and denominator, the same units on my numerator and denominator. I can write this out as 545 over 110 equals x over 53, or I could have written it out the other way. I could have 110 cakes gives me $545 profit, and that's equivalent to 53 cakes per x profit. I'm going to solve the green version that I have here because my x value, my unknown, is on the top, which makes it easier. It makes it a one-step. 53 on both sides. When I multiply both sides by 53, I get 53 times 545. I get 28885 over 110 equals x. Well, if I divide that value by 110, I get 262.591. Well, when I'm talking about values of money, I need to simplify to the nearest hundredths. So they've made $262.59 of profit. Just about $263 of profit. And that makes sense if I'm using my skills of estimation here. 53 pineapple upside down cakes is about half of 110, and 263 is about half of 545. So let's move on and we'll practice again. Now we're going to talk about some percent of change. So a limo, maybe if you're going to prom in a couple years here, a limo costs $85 to rent for 2 hours plus 7% cleaning fee. What is the total cost to rent the limo for 6 hours? Well, this one here, we got a pretty good deal. That's a very inexpensive limo. But let's figure it out. So percent of change, I know that it's going to cost me $85 to rent for 2 hours, but I need it for 6 hours. So let's deal with our percent in a minute here. If it's $85 for 2 hours, I want to know what price it'll be for 6 hours. So when I do that, I multiply both sides by 6, and I get 85 times 6 equals 510 over 2 equals 255. Now I set this up as a proportion because that's the skill we're working on in this unit, but the other way that you could do it is if I know it's this price for 2 hours, I could just multiply that by 3. 85 times 3 should still get me $255. Now I want to know with a 7% cleaning fee. So my next step is I need to find 7% of 255. Well, that percent tells me per 100, so it's 7 over 100, or 0.07 times my cost. And when I calculate that, I get 17.85. So it cost me an additional $17.85. Now what I need to do is I need to add that back to my original quantity. So plus 255 plus that 7% increase. And I get a final cost of $272.85. All right, so now let's talk about another percent of change here. So that one we had a percent increase because we had a cleaning fee. Again, this one we have a percent increase. The current price of each share of a technology company is $135. If this represents a 16.2% increase over the past year, what was the price per share a year ago? So this one here, it's written out as an increase, but I want to go backwards. I want to find that original price, so I'm really going to find a percent decrease. What I'm going to do for this one is I'm going to write an equation. I have some unknown value plus a 16% increase to that value. So a 16.2% increase is times 0.62. And that's going to give me my current price of $135 per share. This shows me that my original plus that increase gives me the current value. So now what I'm going to do when I combine my like terms over here, I get 1.162x equals 35. Now what I need to do is I need to divide both sides by that 1.162. And I'll find my original share. Let's see, 135 divided by 1.162 gives me 116.179, but I'm rounding to the nearest cent because I'm talking about money here, so 0.18. My final answer is the shares last year were $116, and now they're worth $135. So if we invested last year, we'd be making money on this deal. All right, so that's it for your practice problems, and your homework assignment now is a short one. We're just going to take it out of the end of chapter review. So you are just doing page 142, numbers 55 through 70. Go ahead, get those done. I'll have the key posted on Teams so you can self-correct and submit your assignment. Keep going, guys. We have one last lesson before we're going to review and take a test on this material. Thanks.